Write the series using summation notation. So summation notation is when we use the Greek letter sigma, and below the letter we put the number we're going to start with, the term number we're going to start with, which it's easiest if we just start with 1. On top we put how many terms there are. So this is 1, 2, 3, 4, 5. So we put a 5 on top. And then next to it we have to write a rule which will give us each of these terms. So if I look at the pattern here, each term I get by adding 5 to the previous term. And so whenever I add 5, I write that as 5n, which may seem weird, but that's how it works. I'm adding 5, so I write 5n. And then I have to think about if I plug in 1, I don't get 9, which is what I want to get. So I have to either add or subtract something so that when I plug in 1, I'll get 9. So when I plug in 1, I get 5, so I'd add 4 to that to get 9. So this is my answer for summation notation. Write the series and find the sum. So this is kind of a trick question in some ways because we're supposed to go from 1 to 5 plugging into this, and there's too many blanks here, so we don't need those last two. What we're going to do is plug in 1 where a is, so 500 minus 1 squared, and figure out what that is, which that would be 499. That's what would go in the first spot. And then we're just going to keep going, plugging in until we get done with 5, and then we'll add up all our terms. So 500 minus 2 squared is 500 minus 4, which is 496. And then we're going to plug in 3. So that's 500 minus 9, which is 491. And then 4, which will be 500 minus 16, which is 484. And then 500 minus 5 squared, which is 475. When I add these 5 numbers together, I get 2,445. So because it asks us to write this series and find the sum, both parts of this are part of our answer. There is a way to plug this in your calculator. You go to Math, and you scroll up until you see the sigma symbol. But keep in mind, if all you put is the answer, then you wouldn't get all of the points for this problem. But it is a way to check and make sure you're doing it right. Number 3, identify A4. A4 means what is the fourth term. So we could use a formula to do that, or we could just say, that right there is the fourth term. So our answer is negative 30. The sum of the first 3 numbers is what S of 3 stands for. So we're going to take our first 3 numbers here, and we're going to add them together, and that'll be S3. So that means my answer is 39. Use a complete sentence to explain what the pattern is. Now, if all I want to do is know what the pattern is, I'm concerned with either one or maybe 2 things. One thing I want to definitely put in my explanation is how do I get each term, which if I look, I would multiply by -6 to get each of the next terms. The other thing I might want to put in my explanation is where my pattern starts, because in order to actually get this pattern using our complete sentence, we have to know where it starts and what we're multiplying by. So here's a sample sentence that we could write. The pattern starts at 1 and each term is found by multiplying by -6. Okay, so you might come up with something a little bit different than that, but that is the basic gist of what we need in our sentence. The pattern starts at 1 and each term is found by multiplying by -6. Number 6, find or use the appropriate formula to find a of n. Now, we have 5 or 6 different formulas in this chapter, and so it doesn't tell us which formula to use. That's part of the question. And so we want to use one that has a of n, which actually knocks it down to where there's only 2 choices that have a of n. And so the one that we want to pick is the one that has d in it, not the one that has r in it. So that formula looks like this. And so we know what a1 is, we know what d is, and we know what n is. So we're just going to fill all those in. And then type it into our calculator or work it out in our heads, whichever way is easier. And we get -88. And if I were you, if you haven't already, I would try plugging this into the calculator to make sure you know how to plug it in correctly, because that can be tricky sometimes. Number 7, write an equation for a of n by using the given information. Well, they gave us the first term. That's easy. It's -2. And by looking at this pattern, we either know r or we know d, depending on what kind of a sequence this is. So to get from -2 to -8, well, I can subtract 6 or multiply by 4. So which one of those is the pattern here? Well, to get from -8 to -32, I would multiply by 4. So when I multiply by something to get each next term, that means I know what r is. So r is 4. Now, they didn't tell us anything about n because they want us to write our answer with n in it. And so the formula we're going to use, since we have r and we're trying to find a of n, is this one right here. So we're going to fill in a1 and r, but we're not going to fill in n because we don't have anything for n. So this is our answer. Okay, so we've got some more writing here. Fun stuff. So number 8, explain why this infinite geometric series does not have a sum. When we went over 11.4, we talked about how when you put the second number over the first number, you can get r. And so if I do this, and I might get out my calculator to do that, I get 3/2, which as a decimal is 1.5. So what's happening is that if r is bigger than 1, that's when we don't have a sum. So that's one way that we can put our explanation here. Since r is 3/2, r is bigger than 1, which means the sum does not exist. So because we found r and we know that it's bigger than 1, that means the sum does not exist. Another explanation you could give that we talked about is that each of our numbers in our sum here is going up in value, like 3/10 is more than a fifth, 9/20 is more than 3/10, and that pattern will continue. So because each number is going up, that means the sum does not exist. Number 9, we want to tell how you can find the ratio for a geometric sequence when only the sequence is given. Well, that's actually what we just did on number 8. You can divide the second term and the first term to get the ratio or the common ratio. But anytime you have a sequence and it doesn't tell you what r is, that's how we would figure it out. 10. Explain what the difference is between a sequence and a series. This is a really easy thing to forget, but a sequence is a list of numbers, and a series is the sum of a list of numbers. So when we're doing problems, sometimes we're given sequences because they're separated by commas, and then sometimes we're given series, which is when they have plus signs in between because we're trying to add them up. What is the difference between an arithmetic sequence and a geometric sequence? This is another thing that's an important thing for us to know, because it kind of is going to help us figure out like which formula to use and that kind of thing. So an arithmetic sequence happens when you add to get each term. A geometric sequence happens when you multiply to get each term. So the difference between them is how am I getting each term in my sequence? If I add to get them, it's arithmetic. If I multiply to get them, it would be geometric. So this leads us into a couple questions here. Determine whether the sequence is arithmetic or geometric, and then state the rule. So I have to look at what my pattern is. For example, on 12, I multiply by 4 to get each term, which means r is 4, and this is a geometric sequence. Now that I know that it's a geometric sequence, to state the rule, I can use my formula for geometric sequences that looks like this. And so I know r is 4, that's what I'm multiplying by, and a1 is my first term. So I just write an equals negative 4 times 4 to the n minus 1. So there's two parts to this, geometric and then this rule right here. 13, I am adding, and it may be hard to tell for sure with these first two, but look at 1 and 6. How do I get from 1 to 6? I'm adding 5. And then work backwards. Negative 4 plus 5, yeah, that's positive 1. So my common difference is 5, which means this is arithmetic. And so to state the rule, I can use the formula for arithmetic sequences, which looks like this. So an equals negative 9 is our first term, plus n minus 1 times 5. Now, just to warn you, it may be that if this was multiple choice, that they actually might work this out to get a simpler statement. So to do that, we would distribute the 5 and then add our like terms so that we'd get an equals 5n minus 14. So just keep that in mind, that if this right here doesn't show up as an answer choice and you're really sure that, you know, you did it right, you picked the right kind of sequence, then distribute and see if you get an answer choice. 14 is nice enough to give us the formula we need to use. We have a1, which is going to go here, an, which is going to go here, and n is 10, which goes here. So let's just fill it in and work it out. So 10 over 2, and in parentheses we've got 29 plus 119. And so you can type this in exactly the way it is into your calculator, or you can try to work out some of it on your own. This is 5 times 148. And then we would almost definitely want to pull out our calculator because that's a pretty big number. We should get 740. Lots of instructions here, but don't let it overwhelm you. They're telling us what formula to use, and then they're actually also telling us what each letter means, which is really helpful to us. So n is 30 because we're trying to find a of 30. A1 is negative 36, d is 200, so let's fill it in. A30 equals A1 plus n minus 1 times d, which is 200. Well, this I think is going to end up being a really big number because not only are we finding the 30th term, but each term goes up by 200. So I just plug this all into my calculator and I get 5,764. Again, we've got our formula in our instructions, and so we're going to this time have to actually find something. A1 is 2, R, I have to multiply by 2 each time to get my next term, and then n is 10. Now, if you're ever not sure what R is, we would take the second term over the first term and then simplify. So hopefully this one was pretty easy to see that we're multiplying by 2, but maybe if it's a tougher thing to figure out, you do second term over the first term. So I plug everything into my formula, and then I type this into my calculator, and I get 1024. Find the sum of the geometric series. So our formula isn't given here, and that was wrong because sum means I need to use S of n. So we've got to figure out the sum for a geometric series. Since I know what n is, I use the formula that has a1, 1 minus r to the n on top, and then 1 minus r on bottom. So I need to know what my first term is, which is 4, and I need to know what r is. So second term over first term gives me negative 4. So the sum of the first 7 numbers equals 4 times 1 minus r. Put that r in parentheses because it's good to do that when I have a negative that I'm plugging in, over 1 minus negative 4. So I'm going to type this into my calculator utilizing the fraction button, which is alpha y equals. And I get a pretty big number here, 13,108. Evaluate each infinite geometric series described. Now that is a formula that we have. Now remember that we only can actually do this if our numbers are getting smaller in value, or in other words, if our r is less than 1. So in this case, if I want to figure out what r is, I need to do the second term over the first term, which 1/5 divided by 1 is a fifth. So since that is less than 1, I can find the sum of this. So S equals my first term over 1 minus r. So this actually, depending on how good we are at mental math, you can actually do this in your head because the bottom becomes 4/5, and 1 divided by 4/5 is 5/4. But obviously it's fine to use your calculator because that is a little tricky. So the sum of these terms infinitely will be 5/4. On this one though, if I do the second term over the first term to find r, I get 2. 2 is bigger than 1, and so that means the sum does not exist. And we wouldn't want to put it into our formula at all. Evaluate each geometric series described. Series means we're using S. And n must be 7 because this says a 7 here for a of n. So we have to think about the formula for the sum of a geometric series, which we used just a little bit ago. And so I'm pretty sure that we have everything we need. In fact, I feel like we didn't really need a of 7 equals 64, but it is helpful that it told us what n was supposed to be. So now plug in s of 7 equals our first term times 1 minus r, which is 2, to the n, which is 7, over 1 minus 2. So type that into your calculator. And it is a good idea to practice putting this in to your calculator to make sure that you can get the right answer. I get 127. Word problem. A health club rolls its towels and stacks them in layers on a shelf. Each layer of towels has one less towel than the layer below it. If there are 20 towels on the bottom layer and 1 towel on the top layer, how many towels are stacked on the shelf? So we've got like a pyramid of towels going. And so on the bottom one, we've got 20. The next one, we would have 19. And so on until at the top, we've got 1. What we're trying to do is add up the total number of towels we've got. So we're finding a sum. And because the difference between each of these is that if I think of 20 as my first term, then I'm subtracting 1 to get each of my next terms. This is an arithmetic series, and so that's the formula I want to use. Now I have 2 choices for my formulas, and I'm going to write down both, and we can talk about the pros and cons of each. And so it depends on what we know. Right now, we need to figure out what n is for either formula. And so that means how many layers are there. If the bottom layer has 20, they go down by 1 each time, and the top one is 1. Well, that means there are 20 layers, because I have a layer with 1, with 2, with 3, with 4, all the way to 20. So there are 20 numbers from 1 to 20. So either one of these works fine, because I actually know all the information for both, because I know what my first term is, I know what my last term is, but I also know what the difference between them is. So really doesn't matter which one you use, but this one is a little nicer, I think. So the sum of the 20 layers is 20 over 2 times 20 plus 1. So that's 10 times 21, which is 210. So that's how many towels are stacked in that pyramid, which is quite a hefty pyramid that would probably be pretty big. So I don't know if it makes sense to have a pyramid like that. Anyway, that's not the point. 22. Let's solve this equation. This is what was on our last test. So we need to come up with a common denominator for p squared, 5p squared, and p squared. And so it definitely needs to have p squared, but it also needs to have 5. So we're going to multiply everything by 5p squared. So I'm going to write it out the long way. I'm going to take my first fraction and times it by 5p squared over 1. I'm going to take my next fraction and multiply it by 5p squared over 1. And then I'm going to take my last fraction and multiply it by 5p squared over 1. What matters is that I'm multiplying everything by the same thing, 5p squared over 1, so I'm not changing anything. And because I wrote it out like this, I can tell what cancels really easily. Here, the p squareds cancel out, and I'd be left with 25 over 1, which is just 25. Here, everything cancels, so it leaves me with my numerator here, which is p minus 1. Here, my p squareds cancel again, leaving me with 1 times 5, which is 5. And I put a plus sign because of this plus sign. Now, this is a pretty simple equation for us to solve. I need to add like terms here, which is 4, and then subtract the 4 to the other side to get p by itself. So p equals 21. If I look back up here, if I plug in 21 to my denominators, I don't get 0 on the bottom, so 21 is fine for my answer. Same instructions on this one, but this is a little bit trickier. I need to come up with what my common denominator would be, keeping in mind that this would have a 1 on the bottom, and that if I can factor a denominator, that's what I should do. X squared minus x is x times x minus 1. They have an x in common. So what that means is I have an x that I need to be able to cancel out on this first fraction, but I also need an x minus 1. And the 1 here won't matter because it wasn't a fraction anyway. So I'm going to write this out again because I think for some of us that will help a lot. X minus 5 over x times x over x minus 1 over 1. I have a minus sign. So what the minus sign is going to do is it's really like I'm doing plus a negative 1. So put the negative with the top of our fraction times x minus 1 over 1 equals 1 over x times x minus 1 times x minus 1 over 1. So here my x and my x cancels, which means I'm going to have to FOIL x minus 5 and x minus 1. Nothing cancels on my second fraction, so I'm going to have to do negative 1 times x minus 1, which means I'm going to have to distribute a negative x into x minus 1. Here, everything cancels, but what that leaves me with is 1, because when everything cancels, I still had something there at some point, so that's 1, not 0. Now we need to FOIL and distribute, so x squared minus x minus 5x, and then plus 5, first, outer, inner, last. Now I distribute, so that's negative x squared plus x equals 1. So the place that on this you would most likely mess up, to be honest, is not distributing the negative there. I mean, if you get this far, that's a big trick. X squared minus x squared cancels out. Negative x and plus x cancels out, so I have negative 5x plus 5 equals 1. So I subtract 5 and get negative 5x equals negative 4. Divide by negative 5 and get x equals positive 4/5. That's my answer. This is also from our last test. Give the equations of the horizontal and vertical asymptotes. So the first thing that's important to know is horizontal is this direction and is y equals because the point it's crossing is the y-axis. So this is saying that this line is y will always equal 2. So if we look at our choices, that gets rid of these two because these have x equals. So, and sorry, that's a negative 2 because it's down here, not up here, which means D has to be our answer. Y equals -2 and x equals +6 for our vertical asymptote. So notice that if you got the x and the y wrong, you would pick C, and that would be bad. So you need to remember horizontal asymptotes are y equals and vertical asymptotes are x equals. If you forget, you can actually plug in y equals 2 and y equals 6 on your calculator graphing, and it'll graph. Sorry, this was a -2. Man. -2. So this will be the correct line, and this one will not. So that would be a way for you to check yourself. 25. Laura has a drama performance in 12 days. She plans to practice her lines each night. On the first night, she rehearses her lines 2 times. The next night, she rehearses her lines 4 times. The third night, she does 6 times. And that pattern continues. So on the 11th night, how many times has she rehearsed her lines? So the pattern here is that I'm adding 2, which means that D is 2. So I'm going to plug this into my arithmetic sequence generator, which this is my formula for that. I know N, I know D, and I know A1 because that's my first term here. So let's plug all of this in. A11 equals 2 plus 11 minus 1 times D. So this is 2 plus 10 times 2, which is 20, which is 22. You could also just continue this pattern out until you got to the 11th term and find the answer that way. Holes in vertical asymptotes. So we have to factor the top and the bottom to do this. So on top, I have a negative x in common that I'm going to take out, which leaves me with positive x and plus 4. On bottom, x squared minus 16, they don't have anything in common, but I can split it up into what multiplies to get -16. That will cancel each other out so that there's no middle term, which is x plus 4 and x minus 4. So the way this works is what cancels is our whole. So x plus 4 and x plus 4 cancel, which is x equals -4. You set it equal to 0. The vertical asymptotes happen where the rest of the bottom equals 0. So x minus 4 equals 0 at +4. So that's our vertical asymptote. So let's factor on 27. On top, I'm looking for what multiplies to get -12 that adds to get -1, which is -4 and +3. And then on bottom, they have a 2 in common, so I take that out and get x minus 2. So nothing cancels, which means there are no holes. But on bottom, I don't need to worry about the 2 because it doesn't have an x with it. I need to just set x minus 2 equal to 0 so that I know my vertical asymptote is at x equals 2. Now, identify the vertical asymptotes, holes, and horizontal asymptotes. So the horizontal asymptote part of this, remember, is, in this case, my degrees match. They're both squared, so I take 2 over 1 and get 2 for my horizontal asymptote. Then to find the vertical asymptotes and the holes, I need to factor the top and bottom. First, I can take a 2 out of everything, which will give me x squared minus 3x plus 2. But then I'm going to have to factor again. So that's what multiplies to get 2 that adds to get -3, which is -2 and -1. The bottom, when I factor, it gives me x minus 3, and x plus 1. Which means that nothing cancels. And so there aren't any holes, but there are two vertical asymptotes where the bottom equals 0. So that's at positive 3 and negative 1. On 29, my horizontal asymptote, since there's not an x on top, it'd be like an x to the 0. The top is smaller than the bottom, which means my horizontal asymptote is at y equals 0. On both of these, by the way, you can also plug them into y equals and tell using the graph where the horizontal asymptote is. So that's an option if you wanted to do that. We need to factor the bottom. Nothing's going to cancel, so there's not going to be any holes, but we need to factor the bottom to solve the bottom. So I do negative 1 and plus 2, which means my vertical asymptotes are at 1 and negative 2. So last, logarithm. I need to solve for my logarithm. So that means I would subtract 3 from each side, because what's happening is I am adding 3 on this side, so I need to subtract it to the other side. So that's log base 4 of r minus 5 equals negative 2. Now I'm going to rearrange my equation. 4 to the negative 2 equals r minus 5. Which at this point you would probably get out your calculator. 4 to the negative 2 is 1 over 16, which is something as a decimal that I'll get here in a second. Then I add 5 to both sides. And so in my calculator, I'm going to do, if you didn't already do, 4 to the negative 2 gives me, like I said, 1 over 16, which is 0.0625, and then I add 5 to that, and I get 5.0625. Since it's a decimal that ends, we might as well just put all of those numbers. R equals 5.0625. And there you have it.